Hey everybody, Mr. Troy here. Let's find some numbers that make other numbers look like the right numbers. It's time for math with Mr. Troy. Okay, so we are going to solve quadratic inequalities. Here's an example of a quadratic inequality. There are two ways that we are going to consider this. We're going to consider one, putting critical values on a number line or in a table, and we're also going to consider graphing in 2 dimensions. So say you're looking at this and you say to yourself, well, I bet that 0 works for this, because 0 squared is in fact less than or equal to 9. There's a point that works. And I bet 3 works for this, because 3 squared is equal to 9. And now that I think about it, -3 is probably the other important value there. And if -3 works, and 0 works, and 3 works, well, the answer is probably something like this. If you use that approach, but you use it formalized, you're looking for what are called critical values. The sort of thing where you'd say, well, 3 is probably an important number for this x squared problem having to do with a 9. If you take a different approach to it, like this, and you say, well, I know what x squared looks like, and if I plot 9 on that graph, I bet all of this is where the graph is less than or equal to 9. That's a graphical approach in 2 dimensions. We do need to know both of these ways, so as I present you with these 2 ways of doing things, this is not an either or, this is a both situation. So do make sure you know how to do both of these things. Hey, I'm over here now. And now I'm up here. So if you have this sort of situation, the first thing you want to do is you want to set to 0. I can't say set equal to 0 because we're not talking about equations, but set to 0. So we'll actually consider this, x squared minus 2x minus 8, is less than or equal to 0. So you want to start by looking at the zeros of the left side of this inequality. So I'm going to refer to the left side of this inequality like the function f of x. So I'm going to think of the left side of this function as, or the left side of this inequality as this function f of x. And I'm going to find the zeros of that function. And you can find the zeros of that function by factoring, by using the quadratic formula, by graphing, etc. So I know that this factors to x minus 4 times x plus 2, so that I know that it would have zeros at -2 and +4. So on this number line, the way that I'm going to do this for now is that I'm going to write the value at that point over the number line. This isn't something that you have to do in the future. It's just something I'm going to do right now to keep this organized. In this case, both of those values make this inequality true. So right now I'm just marking them with green check marks because they're good. They make this inequality true. This inequality includes 0, so these numbers that turn into 0 work. Now I'm going to pick numbers on either side of each of these critical values. So for example, I'll try 5. And I'm going to use 5 because it's, small. It doesn't matter if you want to plug in here or if you want to plug in here. You should get the same value either way so long as you've factored correctly. So when I plug in 5, I'm going to get 25 minus 10 minus 8, which is 7. So I'm going to write 7 above my number line. Now, 7 does not make this inequality true. If you're good at editing, edit in a big sound effect and like a bonk here. 7 doesn't make the inequality true because I'm looking for things that are less than or equal to 0. Then I'll go ahead and try and plug in an x value like 0. When I plug in the x value of 0, I get -8. Now that does make the inequality true because -8 is less than or equal to 0. Cha-ching! Finally, I'm going to try and plug in something like -3. If I plug in -3, I'm going to get 9 plus 6 minus 8, which happens to also be 7 again, and it's because it's 1 away from the critical value. That's why that number is repeating. Now 7 is not less than or equal to 0, it's greater than 0. Womp womp. So this is going to tell us that our solutions are going to be anything from -2 to +4. Now in the future, you probably won't use that number line approach. You'll probably make a table. So for example, you'd first find your zeros. When you plug in -2, you get 0, and that does make the inequality true. When you plug in 4, you get 0, and that does make the inequality true. And then you would pick these values in between. When you plug in 0, that gives you -8, and that makes the inequality true. When you plug in -3, you get 7, and that does not make the inequality true. And the same thing for 5. So you can either use this number line approach or this table approach. These critical values here, or critical points, whatever you want to call them, are either going to be true or false based on whether or not the inequality sign is inclusive. So that would be how I would get my final interval answer from -2 to +4, and it includes both endpoints. If you're someone who's a very visual person in 2 dimensions, what you can try and do instead is you can try to graph the left side and graph the right side. So because this is my favorite quadratic, I happen to know that it looks like this. Things you know when you're a math teacher, right? It has an x-intercept at -2, a y-intercept at 4, sorry, another x-intercept at 4, a y-intercept at -8, and a vertex at 1, -9. So I just happen to have all of those things memorized because I have to teach it to, hundreds of kids every year and all that good stuff. So what I'm asking is, where is this graph, which is x squared minus 2x minus 8, where is it less than or equal to 0? Now, because the original inequality only has x's in it, even though I can see in 2 dimensions, those are all of the x and y values where the graph is at or below the x-axis, I only care about the 1-dimensional answer of what are all of these x values. So you need to understand these 2 separate ways. There's this 1-dimensional approach where we look at the number line and figure out, is the graph positive or negative? Or you can use this 2-dimensional approach and you can see if the y values are positive or negative. So here's what you might say about this if you were a mathematics textbook. To solve a polynomial inequality, use the fact that a polynomial can only change signs at its zeros. Between two consecutive zeros, a polynomial must be entirely positive or entirely negative. This means that when the real zeros of a polynomial are put in order, they divide the number line into intervals in which the polynomial has no sign changes. So what this is saying is that this polynomial can only change signs at its zeros, which means if we're positive over here and negative over here, we can't be positive again until we've passed a 0. All right, so here's one for you to try, and we'll start with this as our warm-up. All right, everybody. It was only a matter of time before I started playing with the built-in filters. Hang in there. Have a good one. Let me know if you've got any questions. It's not time for math with Mr. Troy anymore. Bye.